Welcome back, everyone, to another deep dive with My Mind Mashups.
It's great to be back.
Today we're tackling a topic that's both incredibly mind-boggling and fascinating. Parallel universes.
Oh yeah, this is one of those topics that really makes you question everything you thought you knew about reality.
Exactly. I mean, is our universe the only one?
Or are there countless other universes out there, maybe even with different versions of ourselves living out completely different lives?
I mean, just thinking about it makes my head spin a little bit. Before we dive into all the complex science behind it, I think it's important to note that the idea of parallel universes, or a multiverse, it isn't exactly a new idea, right?
No, not at all. It's actually a concept that has been around for centuries, popping up in philosophy, religion, and mythology across different cultures.
So it's more than just a modern sci-fi trope.
Oh yeah, way more.
So where do we even begin with the history of this idea?
Well, we can go all the way back to ancient Greece. Philosophers like Anaximander and Democritus were already speculating about the possibility of infinite worlds and universes.
Wow, that's going way back. Like, what were they thinking back then?
Well, Anaximander, he was a philosopher who lived in the 6th century BCE, and he proposed this idea of an infinite number of worlds being created and destroyed over time.
And Democritus.
He came a bit later and was famous for his atomic theory. He believed that everything was made up of tiny, indivisible particles called atoms, and he thought that these atoms could combine in infinite ways, creating not just our world, but also countless other worlds.
So even in ancient times, people were already wrestling with the idea that there might be more to reality than what we can see and experience directly.
Absolutely. It seems to be a question that has intrigued humans for a very long time, and this fascination with other worlds continued through the medieval period.
Really? So even with the dominance of religious thought during that time, people were still entertaining the possibility of multiple universes.
Oh, yeah. Medieval scholars debated this idea within the context of their theological frameworks. It often got tied up with discussions about God's power and the nature of creation.
So it wasn't just pure philosophical speculation. It was also a way of exploring the limits of religious understanding.
Right. And then, as we move into the Enlightenment, we see thinkers like Gottfried Wilhelm Leibniz, a German philosopher and mathematician, introducing the concept of possible worlds.
Possible worlds. Okay, how did that idea work?
Well, Leibniz argued that God, being perfect, would have considered all possible worlds before creating the best one, which is the one we inhabit. So, in a way, he was saying that our universe is just one among an infinite set of possibilities.
Interesting. So it's a different way of thinking about multiple universes, not necessarily as physically existing places, but as potential realities that could have been.
Exactly. And while Leibniz's ideas were primarily philosophical, they laid some groundwork for the way we think about alternate realities.
Okay, so we've got this long history of philosophical musings about parallel universes. But when did things start to shift towards a more scientific approach?
Well, that really took off in the 20th century with the advent of some groundbreaking scientific theories. And one of the biggest game changers was quantum mechanics.
Quantum mechanics. Okay, now we're getting into the really weird stuff. For our listeners who might not be familiar with it, can you give us a quick rundown of what makes quantum mechanics so different from classical physics?
Sure. So in classical physics, which is the physics of our everyday world, things like throwing a ball or planets orbiting the sun, we can predict with pretty good accuracy where things are and how they're going to move. But at the subatomic level, the level of atoms and the particles that make them up, things get really strange.
Strange how?
Well, in the quantum world, things don't behave in such a predictable way. Particles can exist in multiple states at once. They can be in two places at the same time, or they can be both a wave and a particle. And the act of observing or measuring something actually influences its state. It's like reality is fuzzy or undecided until we look at it.
It's almost like the universe is playing dice with reality.
In a way, yes. And this fuzziness, or what we call superposition, is where things get really interesting in relation to parallel universes.
Okay, I'm intrigued. Tell me more.
Well, one of the most mind-blowing interpretations of quantum mechanics is the many worlds interpretation, or MWI for short.
Many worlds interpretation, so multiple universes.
Yes, precisely. This interpretation was proposed by a physicist named Hugh Everett III back in the 1950s, and it suggests that every time a quantum measurement is made, every time there's a possibility for something to go one way or another, the universe doesn't just choose one outcome.
It splits.
Exactly. It splits into multiple universes, with each universe representing one of the possible outcomes.
Okay, let's try to make this a bit more concrete. Can you give an example?
Sure. Imagine a simple experiment where you have a single photon of light, a tiny particle of light, and you shine this photon at a beam splitter, a device that can either reflect the photon or let it pass through.
Okay, so there are two possibilities. Reflect or pass through.
Right. Now, in the classical world, the photon would do one or the other. But in the quantum world, according to MWI, both outcomes happen. The universe splits, creating one universe where the photon is reflected and another where it passes through.
And what about the observer, the person doing the experiment?
They get split too.
Wait, seriously? So there's now a version of me in each of those universes, one who saw the photon reflected and one who saw it pass through.
Exactly. And this splitting happens constantly with every quantum interaction, every tiny decision made at the subatomic level.
So according to MWI, there are countless universes branching off all the time, each representing a different possibility.
That's the idea. And it's not just photons and beam splitters, it applies to everything, every atom in our bodies, every interaction in the universe.
So there could be a universe out there where I decided to have pizza for dinner instead of salad.
And another where you decided to wear that blue shirt instead of the red one, and another where you won the lottery last week, and another, you get the idea.
It's a lot to take in.
Ew.
So according to this interpretation of quantum mechanics, there's not just one me, but an infinite number of me's spread across these branching realities.
That's the implication, yes. It really challenges our traditional notion of a singular self, of a unique identity.
Okay, so MWI is one pretty wild way of thinking about parallel universes. But I understand there are other scientific theories that also suggest the possibility of a multiverse.
Oh yeah, definitely. Another major contender comes from the field of cosmology, which studies the origin and evolution of the universe as a whole.
And that contender is?
It's called inflationary cosmology, and it was developed in the 1980s to explain some of the observed features of our universe.
Features like what?
Well, one of the puzzles that cosmologists were trying to solve was why the universe looks so uniform on a large scale.
Uniform. Like, why isn't it just a random jumble of stuff?
Exactly.
Yeah.
If you look at the distribution of galaxies across the universe, it's surprisingly even. And the temperature of the cosmic microwave background radiation, which is the afterglow of the Big Bang, is also remarkably consistent across the sky.
Okay, so the universe seems to have a certain orderliness to it, even though it started from this incredibly chaotic event, the Big Bang.
Right, and that was hard to explain with the standard Big Bang model. So inflationary cosmology came along and proposed that in the very first fraction of a second after the Big Bang, the universe underwent a period of incredibly rapid expansion, much faster than the speed of light.
So like the universe blew up like a balloon in an instant.
Kinda, yeah. And this rapid expansion, called inflation, is thought to have smoothed out any initial wrinkles or irregularities in the universe, leading to the uniformity we observe today.
Okay, that makes sense. But how does inflation lead to the idea of parallel universes?
Well, some physicists believe that this inflationary process might not have been a one-time event. It might be happening continuously in different regions of space.
So instead of one Big Bang, there could be multiple Big Bangs happening all the time.
That's the idea. This is what's known as eternal inflation. And as these different regions of space inflate, they can pinch off and form their own separate bubble universes.
Bubble universes. Okay, now my head is really starting to hurt. So like, our universe is just one bubble in this vast cosmic foam of bubbles.
Precisely. And each of these bubbles could have its own unique properties. They could have different physical laws, different constants of nature, even different types of particles.
So like, there could be a universe where gravity works differently or where electrons have a different charge.
That's right. It's mind-boggling to think about. And these bubble universes would be causally disconnected from each other, meaning that no information or interaction can travel between them.
So even if we could somehow travel at the speed of light, we could never reach these other bubble universes.
As far as we know, yes. They would essentially be separate realities, existing alongside our own but completely inaccessible to us.
Okay, so we've got parallel universes arising from quantum mechanics and from the very early universe. Are there any other major scientific contenders in this multiverse arena?
Yes, there's one more that we should talk about. String theory.
String theory, the one that says everything is made of tiny vibrating strings.
The very same.
But how does string theory connect to parallel universes?
Well, one of the key features of string theory is that it requires more than the 3 spatial dimensions that we experience in our everyday lives.
Oh wait, more than 3 dimensions.
Yes, to make the mathematics of string theory work, physicists have to introduce extra spatial dimensions, often 6 or 7 more, that are curled up and hidden from our perception.
So like there are these tiny curled up dimensions all around us that we just can't see.
That's the idea. And within this higher dimensional space, our three-dimensional universe might be just one of many. Imagine our universe as a three-dimensional sheet, or a brain floating in this higher dimensional space.
Grains, like membranes.
Exactly. And just as there can be multiple membranes within a larger space, there could be multiple brains, each representing a different universe within this higher dimensional bulk.
Okay, so now we're not talking about universes branching off or forming as bubbles, but more like parallel sheets existing alongside each other in this higher dimensional realm.
That's a good way to visualize it. And some versions of string theory suggest that these brains might even collide with each other from time to time, potentially triggering events like the Big Bang.
So our Big Bang could have been the result of a collision between our brain and another one.
It's a fascinating possibility, and some physicists have even proposed that we might be able to detect subtle gravitational effects or other anomalies within our universe that could provide evidence for these other brains.
It all sounds incredibly complex and theoretical. But let's be honest here. Do we have any actual evidence for any of these multiverse ideas?
That's the million-dollar question. While these theories are mathematically sophisticated and offer potential explanations for some of the mysteries of our universe, direct empirical proof of parallel universes remains elusive.
So, no portals to other dimensions or spaceships that can travel between universes.
Not yet, at least.
But have there been any observations or anomalies that some researchers have interpreted as hints, even if indirect, of a multiverse?
There have been a few areas of discussion, but nothing conclusive. For example, the phenomenon of quantum entanglement has sparked some debate.
Quantum entanglement. Remind us what that is again.
It's that spooky action at a distance that Einstein famously disliked. It's where two particles become linked in such a way that they share the same fate, no matter how far apart they are. If you measure the state of one particle, you instantly know the state of the other, even if they're light years away.
It's like they're communicating faster than the speed of light, which is supposed to be impossible.
Right. And while entanglement is a well-established quantum phenomenon, its connection to the multiverse is more of an interpretation, particularly within the many worlds framework. Some argue that entanglement might arise from these branching realities, with the entangled particles sharing a common history in a previous universe before the split.
Interesting, but still very speculative. What about on a larger scale? Anything in the cosmos that might point to a multiverse?
Well, there's been some discussion about certain anomalies in the cosmic microwave background radiation, that afterglow of the Big Bang that I mentioned earlier.
Anomalies like what?
There are some unusual features, like the so-called cold spot, a region of the CMB that's slightly colder than expected.
And some researchers think this cold spot could be a bruise from a collision with another bubble universe.
It's been proposed, yes. But it's important to note that most cosmologists believe these anomalies can be explained by more conventional phenomena within our own universe.
So, no smoking gun for the multiverse just yet.
Not that we've definitively found. And this raises an important point about the scientific method. A key principle of science is falsifiability. A scientific theory, to be considered valid, needs to be testable and potentially provable wrong.
So you need to be able to design an experiment that could either support or refute the theory.
Exactly. And this is where multiverse theories run into some difficulty. The very nature of many proposed parallel universes makes them incredibly challenging, if not impossible, to directly observe or interact with.
So if we can't observe them or test for them, how can we ever really know if they exist?
It's a valid question. Some argue that the lack of empirical evidence makes multiverse theories more philosophical than scientific. Others suggest that even though we might not be able to directly observe other universes, we might be able to find indirect evidence, like subtle anomalies in our own universe, that could be explained by the influence of a multiverse.
So the jury's still out on the scientific validity of parallel universes.
For now, yes. But regardless of whether we can definitively prove or disprove their existence, the concept of a multiverse has sparked some incredibly profound questions about ourselves and our place in the cosmos.
Absolutely. I mean, imagine if every decision you make, every fork in the road, every chance encounter, creates a new universe where a different version of you takes a different path.
It's a pretty mind-blowing thought. It challenges our sense of identity and the significance of our choices.
Like, if there are countless versions of me out there living out all these different possibilities, what does it even mean to be me? in this particular reality.
It raises questions about free will, too. If every possible outcome of every decision is playing out somewhere in the multiverse, does that mean our choices don't really matter?
Or does it mean that our choices are even more important because they're shaping the specific reality that we experience?
These are the kinds of philosophical dilemmas that the idea of a multiverse throws at us. It's not just about physics, it's about what it means to be human in a potentially much vaster and more complex reality than we ever imagine.
And this brings us to another fascinating aspect of this topic: how the concept of parallel universes has permeated human culture and storytelling for millennia.
Oh, absolutely. Long before we had scientific theories, people were already imagining other worlds and alternate realities in their myths, legends, and spiritual beliefs.
Like, what are some examples?
Well, in Norse mythology, for example, you have this intricate cosmology of 9 interconnected worlds, each with its own distinct characteristics and inhabitants. You've got Midgard, the realm of humans, Asgard, the realm of the gods, and Hel, the underworld, just to name a few.
It's not a scientific multiverse in the modern sense, but it shows a clear fascination with the idea of different realms of existence.
Right. And in many Eastern traditions, such as Hinduism and Buddhism, you find complex cosmologies with cyclical universes and multiple layers of reality. They often describe an ongoing process of creation, destruction, and rebirth across different planes of existence, suggesting a potentially infinite tapestry of interconnected realities.
And it's not just limited to these major world religions. Many indigenous cultures around the globe have traditions that describe overlapping physical and spiritual realms. They often see the world we perceive with our senses as just one layer of a much larger and more interconnected cosmic reality.
And then, of course, we have the explosion of multiverse narratives in modern literature and science fiction.
Oh, yeah, from classic tales like Alice's Adventures in Wonderland to the Chronicles of Narnia and The Wizard of Oz to the mind-bending works of authors like Jorge Luis Borges, Philip K. Dick, and Ursula K. Le Guin, all exploring these themes of alternate realities and the nature of perception.
And let's not forget the huge impact of popular culture, especially in movies and comics.
Right, think about Star Trek, Doctor Who, Spider-Man, Into the Spider-Verse, Everything Everywhere All at Once, and countless storylines in Marvel and DC Comics.
These stories have brought the concept of the multiverse into the mainstream, making it a more familiar and even relatable idea for many people.
It's amazing to see how these modern narratives, even though they're often presented as entertainment, still tap in to those ancient human fascinations with the unknown and the possibility of worlds beyond our own.
It really speaks to a deep-seated curiosity about the limits of our perception and the nature of reality itself.
So as we wrap up our deep dive into parallel universes, we've covered a lot of ground, from ancient philosophical ponderings to cutting-edge theoretical physics, from cultural myths and spiritual beliefs to the explosion of multiverse narratives in modern storytelling. It's a topic that stretches the limits of our imagination and challenges us to rethink our place in the grand scheme of things.
We explored the many worlds interpretation of quantum mechanics, the idea of bubble universes arising from eternal inflation, and the concept of brain worlds in string theory. We delved into the philosophical implications for our understanding of identity, free will, and even the possibility of quantum immortality. And we saw how the idea of a multiverse has resonated across cultures and throughout history, inspiring countless stories and captivating the human imagination.
It's clear that the quest to understand whether we're alone in the universe, whether our reality is the only one, is far from over. While we may not have definitive answers yet, the ongoing scientific and philosophical exploration of parallel universes continues to push the boundaries of our knowledge and challenge our understanding of the very nature of existence.
Absolutely. It's a journey of discovery that invites us to embrace the unknown, to question our assumptions, and to contemplate the vastness of possibility.
Thank you for joining us on this mind-expanding exploration of parallel universes. If this deep dive sparked your curiosity and you're eager to explore more fascinating topics with us, be sure to like, share, and subscribe to My Mind Mashups on your favorite podcast platform.
You can find us on Amazon Music, Audible, Facebook, Pocket Casts, Spotify, and YouTube. We're always diving into new and intriguing subjects, so be sure to tune in next time for another mind-bending deep dive.
Until then, keep those minds mashing.